All right, time for solution number 2 to anagrams. So this one's going to be a little bit more straightforward. Well, I should say a lot more straightforward. But like I said at the end of the last video, it will run into some interesting performance concerns that is something that we're going to kind of use to frame another topic later on in the course. So the first thing we're going to do is a little bit of cleanup of our index.js file. So I'm going to take both the anagrams function and the build char map function. I'm going to highlight it all. I'm going to cut it, I'm going to move it to the bottom of the file, and I'm going to comment both those functions out. So I do want to keep these around just for record keeping. Honestly, it's for you for the future when you come back and review this stuff if you choose to, but we'll keep it there. And then we do need to redefine the function anagrams because we cut and pasted the entire thing. So we'll call string A and string B like so. Okay, so that looks good. Now the second solution for handling anagrams, like I said, is going to be a little bit more straightforward, but like many things that we've seen inside this course, it all depends upon knowing one little trick. So let me show you this little trick. So I'm going to flip on over here. I'm going to make an array, and then we're going to look at one specific method that exists on an array that will make solving these anagram things pretty straightforward. So let's make an array of numbers. I'll give it about 10, 30, 5, negative 90, 1, 10,000, whatever that is. So here's the interesting function that I want to show you. We're going to look at numbers.sort. So when we sort an array, it will take all the elements in the array, and your JavaScript runtime will do its best to figure out how to somehow meaningfully sort the characters, or I should say the elements within that array. Now sort can not only be used with numbers, it can also be used with characters as well. So if we had instead like Z, C, B, D, Y, and then we sort it, we end up with alphabetical order. And so this alphabetical order is what really forms the basis for this alternative solution to anagrams. So here's what we're going to do. We're going to take our two inputs, so in this case like maybe rail safety and fairy tales. We're going to clean up both strings by replacing, or I should say removing, any spaces or punctuation. We're going to lowercase both strings, and then here's the magic part, we're going to sort both strings. So when we sort both of them, no matter what characters we have inside, they will end up in the exact same order. If the two sorted strings are then completely identical, then we can say that we have an anagram. And so when you take this solution, you and I don't even have to do some for loop or iteration or anything like that to look at every single string. We can just sort both these strings and then say, that's it, compare the two, we're done. I think the best way of covering this solution will probably be to write out some code, and then we can copy that code over to this little editor over here and see it in play. I think that'll be the best way of handling this. So let's get to it. So again, I'm going to make myself a little helper function to automatically kind of clean up each of these strings. So remember that kind of replace statement and the two lowercase statement, and in this case, doing the sorting of the string as well. So I don't want to duplicate that logic inside of this anagrams function, so I'll make a helper function to do all that for us. So I'm going to make a helper function called clean string. It will be called with a string. We're going to return the string. We're going to replace, and this will be our regular expression again. So we'll do / square brace, square bracket, caret, \w, and then on the other side of the square bracket, /g. And we'll put an empty string inside there as a second argument. Next, we'll do a to lowercase. And now before we attempt to sort this thing, remember we just looked at the sort method. That is a method that belongs to arrays, not strings. So we do have to temporarily turn this string into an array, sort it, and then turn it back into a string. So we will split this thing on an empty string. We will sort it, and then we will join it back together into a string. So that's a lot of statements chained together into one. Remember, when we consider chaining of methods in JavaScript, we read it essentially from left to right. So first, we call replace, then we call to lowercase on that, then split, then join, then split, then sort, then join. There we go. I think maybe as a quick little test, we should copy this over to that little code editor and just see how this thing works. So back over here, I'll make a short string. Let's say const str is bc. Actually, let's do a real example. How about hello there, like so. And then if I paste that snippet, so here's string replace to lowercase, all that stuff, this is what we end up with right here. So if we then consider some anagram, like let's say string 2, and this one is there, hello. So these two are clearly anagrams of each other. Remember, we are completely ignoring any punctuation. And so if I then do string 2, and then that whole chain, oops, let's clean that up. There we go. So now I've got two strings that I can very easily compare to each other. And in this case, you can see very plainly, yeah, they've got the same characters in the same order, so they must be anagrams. However, if I start to add in characters to one or the other, well, this is clearly no longer an anagram because these two sorted strings over here are no longer equal. So now the last thing to do is to figure out how to actually do that comparison between the two strings. So again, you might be thinking, okay, we have to loop through one string and we have to compare every character to the other string. Well, no, it's actually a lot more straightforward than that. We will call clean string, we'll pass in string A, and then we're going to take advantage of the equals operator. So we'll compare the cleaned up string A to string B. And if the two are absolutely identical, then we must have an anagram. So essentially what we're doing with this line right here is to compare these two strings together. So of course, if we wrote out, let's do this actual statement, if we wrote out, is that equal to that? Well, then we get true. So that's essentially what we're taking advantage of here. We don't have to compare this thing character by character. We can just say, hey, is this string identical to this string? Yes, they are. Okay, well then we must have an anagram. And of course, last thing, never forget it. Don't forget that return statement. Most important part. Okay, so this is the alternative solution. This is another one where once you see the trick, once you understand, okay, we can split it into an array, sort it, and then join it back together and then compare the two results. This is a real easy, maybe relatively easy solution to remember. Probably a little bit easier than remembering how to build the character map on the fly. So yet again, out of so many examples that we've already seen in this course, and so many that we will see as we go through, once you've done these problems one time, you learn that little trick and you'll be able to solve it more easily in the future on an interview. Now, very last thing, I need to save this file and we'll check our tests. So back at the terminal, it looks like all 6 tests are still passing here. Fantastic. Great, so this has been the anagram problem. Again, very common one that I would really expect to see you see in an interview setting. Let's take a break and we'll continue to our next question in the next section.